Dear students, last video I explained few problems on forward and backward interpolation. Now I will explain two important problems on the forward and backward interpolations. Here is an example. From the following table, estimate the number of students who obtained the marks between 40 and 45 by using Newton's interpolation formula. Once again, the suitable method you need to identify. Okay, observe the question carefully. Estimate the number of students who obtained marks between 40 and 45. And observe the given data. Here marks, the second row represents the number of students. Between 30 to 40, we have 31 students. Between 40 to 50, we have 42 students. Between 50 to 60, we have 51 students. Similarly, 60 to 70, we have 35 students. And between 70 to 80, we have 31 students. Now, using the given data, we need to identify the number of students who obtained between 40 and 45. Okay. Now, the procedure is, first we need to rearrange the given data. And we are going to represent the marks as X. So here X represents the marks and Y represents the number of students. So X represents the marks, Y represents the number of students. So to solve the problem, using the given data, we can't solve the problem here. First, we need to rearrange the given data in the form of cumulative frequency. That is, so observe the statement here. If the students scores less between 30 to 40 means this represents 31 students scored less than 40. 40 to 50 means 42 students scored less than 50. Not only 42 students, less than 40 is also less than 50. So 31 plus 42 students scored less than 50. So how many students have scored less than 60? 31 plus 42 plus 51. So using that concept, we need to construct the new table. That is, observe the statement here. The number of students who scored less than 40 is given, that is 31. The next point, the number of students who scored less than 50, 42 plus 31 gives 73. The number of students scored less than 60 is nothing but 31 plus 42 plus 51. Gives 124. Similar to that, we need to find out the number of students who scored less than 70, means the addition of these four. That gives 159. The number of students who scored less than 80 is nothing but addition of all the data. So 31 plus 42 plus 51 plus 35 plus 31, that gives 190. So now I am rearranging the given data in the form of, observe here, where X represents the marks, Y represents the number of students. The student who scored less than 40 is 31. The student who scored less than 50 is 73. Less than 60 is 124. Less than 70 is 159. Less than 80 is 190. So this is, I am rearranging the given data. Now, what we need to find out here, we need to find out the number of students scored between 40 and 45. For that, I want to know how many students scored less than 40 and how many students scored less than 45. The first data is given. The number of students scored less than 40 is 31. So now I want to find the number of students who scored less than 45. Means find Y at X is equal to 45. At this point, I want to find the value of Y. Now the procedure as it is. But here, the important thing is rearranging the given data. Now, I will find the value of Y when X is equal to 45. Observe this X is nearer to X naught. So which formula is the suitable one? Newton's forward interpolation. For that, we need to construct the table. As usual, first X value, next Y value. and then the first order forward difference, that is 73 minus 31 gives 42, 124 minus 73 gives 51, 159 minus 124 gives 35, 190 minus 159 gives 31. So this completes the first order. Now find out the second order. The difference of these two, 51 minus 42 gives 9, and then 35 minus 51 gives minus 16, and then 31 minus 35 gives minus 4. Okay, this completes the second order. Now find out the third order. The difference of these two is minus 25. Minus 16 minus 9 gives minus 25. Next, 4 minus of minus, so plus 16. So sorry, here minus 4 we have, and this is minus 16. So minus 4 plus 16 is plus 12. Now the difference of these two, 12 minus of minus 25 gives plus 37. So this is my table. Only fourth order, no fifth order, because we have a singleton element here. Now consider the Newton's forward interpolation formula. We defined up to fourth order, so consider the formula also up to fourth degree term, the fourth order. We need to find out R here. I am using Newton's forward interpolation, so the formula for R is x minus x naught by h. What is x? At 45 I am finding y, so x is 45. X naught is the first value of x, that is 40. Step length, the difference between consecutive values of x is 10, so step length is 10. So you will get 0.5. Now substitute R is equal to 0.5. Y naught is 31. So this is the initial value of y. Y naught is 31. Delta y naught means the first value in a first order. Delta square y naught, the first value in a second order. Delta cube y naught, the first value in a third order. Delta power 4 y naught, the first value in a fourth order. Now substitute all the values, you will get some value here. The value of y at x is equal to 45 is 47.87. Here we are finding the number of students. This means usually the number of students is not in the form of decimals. So write down its approximate value. 47.8 is nothing but 48. So this is the number of students scored less than 45 marks. So 48 students scored less than 45 marks. But this is not my final answer, because I want to find between 40 and 45. So to get the final answer, hence the number of students getting marks between 40 and 45 is, first consider the number of students scored less than 48 minus consider the number of students scored less than 40. That gives the number of students scored between 45 and 40, that is 17 students. So this is a very important problem, so concentrate on this problem. So similar to this, I will give one more problem as an assignment in terms of population. So you need to try that problem. I will send the assignment later. Now I will explain another problem that is different from this type of problem. That is construction of interpolating polynomial. So construct interpolating polynomial for the given data. We already constructed a polynomial in Lagrange's interpolation. Almost same procedure here also we are going to use. Here I gave some data. We need to construct the polynomial which satisfies the following data. Means you will find out some polynomial. In that polynomial, if you replace x is equal to 0, you will get the functional value as 3. When you replace x by 1, you will get the y value, that is functional value, as 6. Similarly, these values. Okay. As usual, first construct the table. Forward interpolation table, forward difference table. First column is x, second column is y, and then the first order, third order. You know how to find out the table already, so I no need to explain again. So here you can stop the problem only for third order, because in the third order all the values are 0, so no need to go for fourth order. because 0 minus 0 gives 0 only, we know that. So no need of fourth order, we can stop up to third order. Now here you can use the forward or backward anything formula. Any formula is suitable, is convenient for you. Preference is given to the forward interpolation, so I will consider forward interpolation formula up to third degree. Fourth degree is also 0 here, no need of this term. If you want, you can consider, no problem. So first I will consider the forward interpolation formula. The difference is, observe the previous problem here. We find out the value of r as some real number 0.5, means by taking x value, x0 value and step length and everything. But here when you are finding a polynomial in r, I will keep x as it is. I will replace only x0 and step length. What is x0 here? 0. What is the step length here? The difference is 1. So 1. So x as it is. When you are finding a polynomial, keep in r, keep x as it is. So r in terms of x you are going to get. If x0 is 1, x minus 1 by 1, so that is x minus 1. If x0 is 10, x minus 10. If step length is 2, then x minus 10 by 2. You will get like this. But in this problem, x0 is 0, step length is 1. So r in terms of x is x only. Now substitute everything. Y0 means the initial value of y. Substitute here. R, I am going to substitute r in terms of x only. Delta y0 means the first value in the first order of our difference, that is 3. Delta square y0 means the first value in the second order of our difference, that is 2. And observe, x, r is x into x minus 1 by 2 factorial, and here x into x minus 1 into x minus 2 by 3 factorial into delta cube. Delta cube is 0, so I will substitute here. And fourth order is also 0, so 0. So this term vanishes because I am multiplying by 0. Now you need to simplify these three terms. 3, consider here, 3x, consider here, 2 factorial and 2 gets cancelled, so multiply here x square minus x. So if you simplify this, you will get a polynomial x square plus 2x plus 3. So this is called the required polynomial, interpolating polynomial, x square plus 2x plus 3. So this is my answer. In some cases, you may get a cubic. If the third order is non-zero, you will get a cubic equation. Or if the fourth order is non-zero, you will get a biquadratic, means degree 4 equation. Now to verify your answer, you can replace x is equal to 0. If you replace x is equal to 0 here, you will get y is equal to 3. That is a given value. To check one more value, replace x is equal to 1. In the polynomial, what happens? 1 plus 2 plus 3, you will get 6. Similarly, you can replace with the 2, 3, 4. You can verify all the values. You will get the given y values. So this is another procedure of construction of interpolating polynomial. Remember, when you are going to finding an interpolating polynomial, in the formula, you need to write in r in terms of x factors. X minus a with some step length. Sometimes the step length may be 2, 3, 4, anything. Here a may be 0. In this problem x0 is 0. So that's why we get only x. Otherwise in some problem we are going to replace r by x minus 1. Okay. Or in some cases x minus 1 by 2. That depends on the given data. So this is another working procedure to find the interpolating polynomial. Is that clear? Sometimes after finding interpolating polynomial we may ask, hence find y at x is equal to 5. It's nothing but in this polynomial replace x is equal to 5. So what happens here? 25 plus 10 plus 3. So 35 plus 3, 38. So the value of y when x is equal to 5 is 38 by using interpolating polynomial. Okay. So concentrate on these two problems. Usually in the examination you are going to get problems like this. Not only in the examination, in application oriented problem also. The problem number 6 is very important. Now here I am giving some assignment problems. Observe here, we need to find the value of y when x is equal to 8. Given some data, x starts from 1, 3, 5, 7. So the difference is 2, so the step length is 2 here. And observe, we are finding the value of y when x is equal to 8. This is nearer to the final value of x, so use backward interpolation formula. Okay. Now the next problem. The following table gives the melting point of an alloy of lead and zinc. T represents the temperature in degrees Celsius and P is the percentage of lead in that particular alloy. So here is given data. Using this data, we need to find the melting point of an alloy containing 84% of lead. Means 84 means nearer to 90, not 60. So nearer to 90 means, once again I want to use backward interpolation formula, where I want to treat the percentage of lead as x and the temperature as y. Find y when x is equal to 84. Nearer to 90, the final value, so use a backward interpolation formula. Next problem. The following table gives the distance in miles of a visible horizon for the given heights in a feet above the earth's surface. Okay, fine. Now here we need to find the value of y when x is equal to 160. So this is 160, not 160, 160. So now here this 160 is nearer to 100 compared to 400. So when you are going to find the value of y when x is equal to 160, use a forward interpolation. And similarly, when you are going to find the value of y at x is equal to 410, this is nearer to xn. So here use the backward interpolation. So at 160 use the forward interpolation, at 410 use the backward interpolation. Next problem, this is the problem I told. The following table gives the population of a town during the last 6 census. Estimate the increase in population during the period from 1986 to 1988. Okay, fine. Now here the population given in terms of year 1921, 1931, 1941, 51, 61, 71. Given in terms of this. So no need to find the cumulative frequency. Just construct the table using the given data. Using the given data, you just construct the table. First, find the value of y. I will treat the population as y and year as x. Find the value of y when x is equal to 1986. And once again find the value of y using x is equal to 1988. Observe, both 1986 and 1988 is nearer to the last value of x. So use backward interpolation formula when you are going to find the y at these 2 points. After finding this, we need to find out the difference between y of 1988 minus y of 1986. The population in the year 1988 minus the population in the year 1986. That gives the increase in population between these 2 years. Is that clear? For both procedure, we are going to use backward interpolation because both are nearer to xn. Next, given sine 45 degree. So this represents sine x degrees equal to y. So x is 45 degree, 50 degree, 55 degree, 60 degree. Y is nothing but right hand side value. Okay. So using this data, find sine 52 degree. So this is nearer to 45. 52 is nearer to 45 compared to 60. So use forward interpolation formula. Here only given forward interpolation formula. So no confusion. It means I am finding the value of y when x is equal to 52. Now construct the polynomial. So here first you need to construct the table and we need to find out r is equal to x minus x naught. I will take in a forward interpolation x minus x naught. What is x naught here? 10 divided by step length. What is the step length? Difference is 1. So r is equal to x minus 10 by 1 means x minus 10. So when I am going to construct the polynomial for this problem, I am replacing r by x minus 10. Okay, replace, you simplify, you will get one polynomial. If you want, you can verify these values. Later in that polynomial, replace x is equal to 12.5, you will get y value. So next problem, Once again the same thing, cubic polynomial. So he given you will get a cubic polynomial. So here values by using interpolation formula means some polynomial satisfy this data. Once again here r is equal to x minus x naught by step length. So what is x? X as it is. What is x naught? 0. What is step length? 1. So what is r here? X. So in a forward interpolation formula, replace r is equal to x to get a cubic polynomial for the problem number 7. So this is your working procedure for these 7 problems. I want this assignment within June 5th. Okay. If you have any doubt, you can schedule live Zoom meeting or Impartas at any time if you want, or you can call me, or you can drop a message regarding the problem and your question, what you have a doubt. I will explain through the phone. Okay. Thank you. Continue in the next video. Good luck.